مرحبا.
Hola.
I'm inspired that there's so many people working to accomplish the same goal of creating a connected future.
By having students lead clubs on campus directly supported by Google developers, that's the best way to reach out to students.
It's really inspirational always to hear about members of the community who echo your values and echo your beliefs.
I've been listening more than I've been speaking, and I don't necessarily think that's a bad thing because I'm just getting all these ideas.
Google needs to reach a wider audience and be more relatable as a company, and I think Google is one of the brands that is very good at doing that.
Hello everyone. Welcome to the second event. It's the two of us again. We're going to be covering some sorting algorithms and just algorithms in general. So thanks again everybody for the awesome feedback from the first session. We want to kind of keep it going, keep it steady with our second event. I'm just going to do some housekeeping. So I will show anybody who is new, welcome to our channel. I'm going to show some housekeeping things, considering how to ask questions, how to communicate with us directly, and then we just go straight into it. So yeah, I think that's the plan. So we have our own Discord server that you can see right now on your screens, and also the link on your screen as well. So when you enter the Discord server, just make sure you read through the rules. We want all the conversations to be peaceful and kind of respectful to all the parties. So please read through the rules, see if you agree with them, and if so, just hit this check mark over here, and you will get access to all the awesome channels that we have. You can see that we have a bunch of developer series, Flutter series that we ran last, I think it was like October, November. Firebase series, check it out if you're into that kind of thing. We have a lot of events on Firebase and Flutter, and also we have our brand new data structures and algorithms channel. Thanks, by the way, there was an awesome comment posted recently about different, people were asking where you can learn different algorithms and where you can practice. So thanks to Luke for posting this awesome lineup of things where you can go and like learn things from, right? So yeah, definitely check it out. We're active on here. If you have any questions during the session, after the session, we will be more than happy then to help you. Cool. Okay. So let's actually go into, actually, by the way, if you're not, if you don't want to, if for some reason join the Discord server, YouTube comments are also, or any kind of comments are also a good place to ask us. We will be active throughout the session. Alexander will present for the most part, but I will also be answering the questions during the session. Cool. Okay, so let's get to it. I'm gonna pass the word over to you, and we'll go there.
Yeah, before we start, okay, cool. Anyways, so hello everyone. Thank you, Andre, for the introduction. And today we are going to talk about common sorting algorithms and just algorithms in general. So again, it's me and Andre who are going to present today. So we had another session which was called Algorithms and Data Structures Overview, like introduction, last time, 1 week ago. So if you want to go and check it out. and this is the second event of this event series, so it is dedicated to common sorting algorithms. Next week on Saturday, we are going to have graph traversal and pathfinding, so which will conclude this event series for now. Maybe later there will be an extension of it, so we'll see. Let's just go over the agenda. So yeah, we will have like brief, like we had brief intros. We are going to talk about, again, sorting algorithms, then bubble sort theory and demo, merge sort theory and demo, and Q&A. So we will cover, like, just we'll take a look at different sorting algorithms, but we will implement only bubble and merge sorts, because they still, one is easy, another one is intermediate. So you will be able to try to do both of them. So I hope you will like it, and let's get started. So, well, the first part is sorting algorithms. So here, so let's define what the sorting is. So first of all, like sorting, you probably know what it means, right? Like the word to sort, the verb to sort is very familiar to you. You probably do it all the time in your life, and especially if you're a programmer. Essentially, if we want to define the term sorting, we would say it is rearranging items in a collection to achieve a certain order. So you can sort by numbers in different order, ascending or descending. You can sort by strings, right, by alphabet characters. So A is before then B, again, ascending or descending, then by objects, so by object properties, essentially, and many other ways, right? So in this event, we will focus only on sorting numbers in an array, okay? Since it's like the easiest version for us, just to learn the algorithm itself and not to focus on different things that would distract you. So essentially, if you master sorting numbers in an array, then you will be able to sort whatever you want. So yeah, that's about sorting.
I think like part of the reason why we focus on numbers and like most of like sorting algorithms so focus on numbers is because it's the easiest to define what is like one object is less than the other object. That's kind of more difficult to define, right? Like with numbers, it's easy. You can just use the less than or the greater than operators. With strings and objects, you need to kind of go and define. We'll talk about like what is a comparator function, which is used when you want to sort an area of more complex things. But yeah, for like the simplicity's sake, we'll just focus on numbers this session.
Okay, cool. Yeah, it's a good point. Yeah, you will just will be able to replace numbers with whatever you want in the future. So yeah, like again, this is just this series is to get you started with algorithms and specifically sorting. So yeah. Now let's talk why we need to learn sorting, right? So probably you've heard of it before, like maybe you even tried some algorithms. So again, sorting is a very common task, especially in programming, and it's good to understand. So then you need to be aware of advantages, disadvantages of specific algorithms. So for instance, in special situations, you would want to use one or the other. And I know that in most of the programming languages, including JavaScript, that we will be using today, there is a built-in sorting function, like sort function, but sometimes, I don't know in what cases, but maybe you will encounter it in your career that you probably want to use a different sorting algorithms, a different sorting algorithm, and you probably would say, oh, I don't like this. I want to try another version because it will be more efficient. And since you have a huge data set, yeah, this algorithm will be better in this case. So this is one reason. Then, okay, then interviews, right? So again, it's just generally good exercise to train your brain to think about different unusual scenarios, right? Because as a programmer, you need to have critical thinking skills, and like essentially sorting is kind of basic topic that helps you, again, think about the basic thing like sorting in different ways, right? So, and then,
And I think also, like, to be completely honest, you will probably not find yourself writing your own sorting algorithm for the most part, right? You probably will use something that is built in the language that you're using. But like, I personally, for me, I think I want this session to be like an example of how you would take an algorithm, understand it. We will show you how to understand the complexity of it. So we talked about big O notation last time. So even though you will probably not apply these concepts a lot in your like programming career, but nevertheless, like, this is a great example of using some data structures that we will show today. We'll show the tree data structure, right? Like, as we go, that will be more evident. But this is like, sorting is a great example of what an algorithm looks like, how you would analyze one and present one. Maybe it won't be the one that you will get on your interview, but we'll show you how to be how to describe the algorithm in depth.
is a good point. So let me switch for a second. So here there is a website called I don't know how to pronounce it, but anyways, what it does, it essentially has different sorting algorithms, and it compares one with the other one. So if we launch this, so this is a random array, and if I click sort, you see how different algorithms work. So now you can see that selection sort is very slow, and usually it's the worst one. So
Can you make it a bit bigger, a tiny bit bigger, if that's possible?
Okay, sure.
Yeah, perfect.
Is this better? Okay. Yep. So again, if I do this, so again, you can see that the fastest maybe is a heap sort, then I know quick sort and merge sort, and then less fast algorithms like bubble, selection, insertion, shell, right? Again, it depends on a situation. So it just sorting, again, it just to get you started isn't reset, right? So to apply some concepts that we introduced last time, like we will measure big O, we want you to practice some code, so we also will do a little demo. And then again, you just need to think about different situations, right? So what if we have random array, right? So probably in this case, you would want to apply merge sort, right? Or heap sort. But what if you have like reversed, right? So we find out that probably the most efficient one would be shell, or again, heap. So based on different situations, you want to use different algorithms. So yeah, it just, if you want to play with this website, it's called Top Tell. Yeah, and just you can just click random buttons and yeah, find out how it works. Yeah, just to see how the algorithms work. And now let's go to another slide. So yeah, before actually we start talking about different sorting algorithms, I want to talk about JS, JavaScript built-in sort function. So again, this is probably just specific to JavaScript, what I will tell you right now, but it's very good to know, I believe. So imagine you have an array of strings, right? So you have March, January, February, December, and then you just want to sort this array using the JavaScript built-in function. And when you console.log it, so line 3, you get this expected output, which will be essentially a sorted array of strings. So December, February, January, March. So, and essentially this is correct. Why? Because this is the order of the alphabet, right? D, then F, J, and M. But there is a problem. What if we have numbers? So in JavaScript, this is like a tricky part where you may be a little bit confused, because when you have an array of numbers like 134, 21, whatever, and you apply this sort function on this array of numbers, you get something very weird and unexpected. And you see 1, then 100,000, 21, 34. And this is not the order how you normally would imagine it. So the reason is because this function sorts by ASCII characters like this one. So if you just open a table and like read, just type ASCII, and you will be able to see American Standard Code for Information Interchange. So when you have this table, so essentially what it means, every character has a corresponding number. So for instance, we can see that capital W is 87. I'm not sure if you are able to see it clearly, but yeah, just type it in Google and yeah, find it out. So here if you find it in the internet, 0 starts from 48 and 9 is 57. So this is how this sorting function works, essentially. So it does not sort by value of the number. It sorts by this ASCII characters. So if I go in here, yeah, you also can check this MDN Mozilla array.proto.sort. So essentially it just describes what I'm going to say and how to fix it, right? So if you want to sort by normal values. So, okay. The solution is actually to have a comparator, I hope I pronounce it correctly, function. So you just need, this is a callback function that you put into the sort function, built-in JavaScript function. So in this case, you'll just compare numbers based on values. So in this case, if we have an array, like we pass an array of, imagine, where is it? Imagine we define this comparator function, we put it as a callback, and then we would get a normal order in here. So it will be 1, 4, 21, 30, and this number. So how it works, you essentially have two parameters. So imagine you have 1 and 30. So it compares like different sets of numbers together. And so 1 and 30, right? So what it does, if you pass 1 and 30 here, 1 minus 30, it is minus negative 29. So it means the second number is larger, right? So you need it to live in its spot. But imagine you pass, I don't know, 102. Then you say 100 minus 2 is 98. And what it means that the first number is larger than the second number, and you need to swap them. So essentially, this is how this comparator function works. And if you want to read it more in depth about it, you just can check this box. And again, they describe it in more detail. So specifies a function, if we just read the definition of it, specifies a function that defines the sort order If omitted, the array elements are converted into strings, then sorted according to each character's Unicode code point value. So, and again, you can just read all that stuff here. So to make it, maybe to clarify some moments and some questions that you may have, obviously you can ask them here.
Just one small comment that like I personally like to think about the comparator function is that if you have like JavaScript will use that function to determine if your array is sorted or not. So it's going to apply, like think about it, if you have a sorted array and you apply the comparator function to each pairs of consecutive numbers, if you apply it to 1 and 2, 2 and 3, and so on, all the result of the comparator should always be negative, right? Because 1 minus 2, negative or 0. 1 minus 2 should be negative, 2 minus 3 should be negative, and so on. And yeah, it's like if your result is negative, that means that B is larger than A. If your result is positive, that means that A is larger than B. Just think of it as the definition of what it means for A to be smaller than B, and that's going to be your order of things. And you can imagine that A and B could not be numbers particularly, right? Like in this scenario, they could be objects or strings. But yeah, that's what you would use to sort more complex arrays as well.
Yeah. And also important moment here, this is to sort in ascending order, so 1, 2, 3, 4, 5. If you want the other way around, you would need to swap B and A in here. So it will be return B minus A. So this would be in descending way. So yeah, you just need to understand, again, ascending or descending, and based on this, you would define your comparator function. Okay, cool. So now, finally, sorting types. So to be honest, I do like sorting algorithms generally because, again, like it's a good introduction to algorithms, and to wrap your head around different concepts and maybe apply some knowledge that you may have. Like merge and quick sorts are good to practice your recursion. Yeah, just good stuff. Actually, I didn't show you. There is a video on YouTube that is called 15 Sorting Algorithms in 6 minutes. So essentially just shows you how algorithms work. So different ones, so 15 different sorting algorithms. So this is selection sort, then you have insertion sort, like merge sort, heap sort, then radix sort, and etc., etc. Yeah, we'll not go over all of them. Yeah, so this is Babel. And today we are going to have theory, so we will talk in detail and then implement Babel and merge sorts. So I believe it doesn't matter what to program, like if you know basic concepts of programming, you should be able to implement Babel sort with no problem. Yeah, merge sort, it's kind of a little bit tricky, so do not worry if you are a little bit confused. Like right now, you just need to focus on understanding how these algorithms work, right? And after like a couple of when you implemented this algorithm, like try it by yourself, maybe you will be able to implement alone. But right now, again, our goal is to understand, again, the concepts and generally how these sorting algorithms work. So yeah, now let's talk about Babel sort first. So Babel sort, yeah, funny name, good name. It actually is called this way because you babel the largest value up. So let me, before I show the next steps, I just want you to introduce to the website called Wijalco. Yeah, so it's a cool website. It essentially just has different sorting algorithms, and it shows you step by step how each one works. So again, if we talk about Babel sort, we bubble the largest value to the right. So now I know it may sound weird, but just wait a second. So if I run go, and then I will go step by step. So here, let me close this. Here, imagine we have an array of 6 different values. So we have 3, 44, 38, 5, 47, 15. So now the first pair, again, this is like just a description of the algorithm. So you kind of get initial idea how this algorithm works. So we have the first pair that we compare, 3 and 44. So we compare what is the bigger value. 44 is bigger than 3, so we don't swap anything. The next pair we compare is 44 and 38. So 44 is larger, so we swap. So we bubble the larger value up. Then the next pair we compare is 5 and 44. 44 is larger than 5, so we do a swap. So we bubble 44 up. Then 44, 47. 47 is larger, so we don't do any swaps. And then 47 and 15. 47 is larger, so we do our final swap, and we bubble 47 up. And what happens now, if you can see, we iterated essentially over all the array, and we find out that 47 is the largest value, and we put it to the right. Again, it doesn't make sense. So we bubble the largest value up. So if you like, if I go through this, so again, the next 44 is bubbled up, and then the next would be 38, and then we find out that everything is sorted and we are good. So again, I hope this makes sense. Again, we will go over a bit over it now more in detail, so don't worry. So I have the same example here with different values. So 9, 5, 4, 10, 3. Again, we compare to adjacent values, right? So 9 and 5, what is larger? 9. So we do swap, right? And the next pair we compare is 9 and 4. 9 is larger, so we do swap. And then the next set of values we compare is 9 and 10. So we do not swap because 10 is greater than 9. The last comparison we make is in this iteration is 10 and 3, and we find out that 10 is bigger than 3. So we swap, and we end up with 10 as sorted. And all the rest array is not sorted yet, but we know for sure that the right part is sorted, right? So 10 is in its place, okay? So this is essentially how bubble sort works. Like, I hope it's not complicated. Now we will start implementing this function, and I hope it will make more sense as you get some practice with it. So let's try. Before we implement the bubble sort function itself, I just want to write function number 1 which is called swap. So it's essentially, how do we swap values in an array, right? So how do we do this? How do we swap 9 and 5, right? So this is essentially a solution. Let me open some stuff right now. Okay, now I will show my code in Google Snippets. So because I believe all of you have that stuff. So to access, if you have Google Chrome, then you definitely have Snippets. It's a special tool in developer tools in Chrome. So to access it, you can go right-click anywhere in Google, click Inspect, then in Sources, you click on Sources, and then if you don't have Snippets selected yet, you just go here, and you should find it either here or here. And then to create a new snippet, you just say New. new snippet, and here you say, I don't know, you can call it whatever you want, like rename, and you can call like swap camo. Okay. So in this case, we will just implement this function here. If you want to use a different IDE, like you have some preferences, maybe you like Visual Studio Code and you work with it, and you know, like its functionalities, how to debug and do some stuff. So again, it's up to you. You can use any IDE you want. It just I'm showing this because it's universal, so I believe most of you have access to Google and to Google Snippets as well. The reason why I want again this Google Snippets, because when I explain merge sort, this pane on the right, panel on the right, it will be helpful to analyze the algorithm. But for now, yeah, it just for me it's convenient because I don't need to open anything else. So yeah, it's up to you again. If you want to use a different IDE,
just a bit bigger, so it's easier to see.
Yeah, sure.
But yeah, like as Alexander mentioned, like I think I also agree that DevTools snippets are a great tool, and especially if you want to quickly test some function that you're writing. It's not like a big, huge infrastructure that you're managing. Google Snippets are ideal for that. But also feel free to use any IDE that you're comfortable with. If it's VS Code, VS Code. Just kidding. If you're like IntelliJ or like Notepad++, whatever you're comfortable, feel free to use that. We're going to be using this since, yeah, everybody has a Chrome browser and you can just go into it and try some code out.
Yeah, and you don't need to install anything essentially. So yeah, okay, let's just jump into implementation of this function. So again, we implement the swap function first, since we understood that it is essential for bubble sort. So let's just, so imagine we have like how it should work. So this is the case. So I have an array, imagine I have an array, and I pass it, and I have function swap, which accepts like an array, and then the first index, it's and the second index are in the array is are the places where you want to swap the values, right? So in here, I say array, so I pass array in here, and then I say 0, 1. So 0 array at index 0 is 3, and array at index 1 is 1. So this is in this way, I'm saying I want to swap 3 and 1. So I want to swap values at index 0 and at index 1 in this array. Okay. So I hope it's not hard, like, to understand how it works. And then I end up with I should end up with this result. Again, I didn't implement it yet, so don't worry. We'll just write this function now. So imagine I have a swap function, right? So we just define a swap function, and then I pass an array, then index 1 and index 2. So these are indices where I want to swap the values at, right? So to do this, we just need so again, it's just 3 lines of code. It's not something complicated. I will just write, and then we will go over this example that I have. So we need to create a temp variable, which is array at index 1. And then we do array at index 1, and we assign it to array at index 2. And then I have array at index 2, and I assign it to array at index, no, it's not array at index, it's 10. Okay, cool. So if I didn't do any error, that should be fine. So let's just put a breakpoint here. Like, let's just run it and ensure that we have this result. So to run, you can press I'm running Windows. So if you have Mac, you will have like a hint here. So either you can press this button, where in Windows you can press Control Enter, or in Mac I'm not sure. So yeah, you will be able to see the shortcut here. So yeah, but just click this button, and then you will be able to see that the result is correct. So it's 1352, right? So now I will put a breakpoint here, and we will debug okay, we will debug this function. So I just run, and now we will take a look at it step by step. So let me.
Sorry, before we do that, just quickly answer a question that we had in the chat.
Sure.
So Alejandro is asking, what is let when you declare variables in JavaScript?
Okay.
You want to take that?
Yeah. So this is I'm not ES6, I believe. So JavaScript has different versions, right? So EX6, ES5, 5, etc. So JavaScript gets updated, I believe, every year right now, and this is like a standard, I would say, in JavaScript. So ES6 standard that like you can follow if you want, or you should follow. Alternatively, you can just use var. So it doesn't make any difference. It just like a new standard that was introduced to JavaScript, right? So
there are nuances to what declarations you use. So there's 3 main methods to declare variables. It's const, let, and var. You can also just declare a variable without anything, but that's very uncommon. You can, if you want to, you can read about the differences between them. But right now, usually people just use const and let. If you want to change something, you use let. If you have a constant variable that's never going to change, you use const. Var is always never used in modern JavaScript. But
yeah, if you want to check new versions of JavaScript, just say like type ES6 or ES7. You see, and you will be so ECMAScript. It stands for ECMAScript, and then you will just be able to see different updates to JavaScript. So yeah, but generally, again, this is, don't worry about it. If you want to use var instead, like this, it doesn't make any difference. Okay? So let it just to declare a variable is used to declare a variable. So now let's just, I hope this answers your question. Let's just go over this example. So here on line 8, I call this function with the array, which is this. So, and you can see here it gets passed. So it's 3, 1, 5, 2. And then I say index 1 is 0, as you can see here. And index 2 is 1. So you can see it here, right? Now I declare a temp variable, and I assign it to array at index 1. At index 1, so it will be array at 0, which is 3, right? So let me go to the next line, and now you can see temp is 3, right? Then array at index 1, which is currently array at index 1, I mean, this array at 0 is 3. And then you replace it with the array at 1. So it will be 1, right? So, and this is how, at this point, how our array looks like. And then I say array at index 2 is temp. So, and temp of 3. So I just change it this way. So this is, again, this is just to swap the values. You just need this function to implement bubble sort. So if you are a little bit confused, again, you just create a temp variable and you just store temporarily a value that you want to swap, and then you just swap the values around, and that's it. So if probably later after the session you would like to go over it again, and that's totally fine. But I hope it's not hard to understand. And again, we will just now go to the next stage. So again, swap is just to swap the values. Okay, just Andrew, are there any questions in the chat before I go further?
Yes, actually, we have one one question which maybe you will have a better grasp on. So basically, Dmitry is asking is which way of sorting is faster, using one additional variable, or using two starting variables with adding a subtraction swap. Like if I understand that question correctly, like it shouldn't matter. Even if you use like one or two, it's like a constant number of operations, which is still O of n. Sorry, O of one.
O of one.
So the swap complexity will not change.
So
yeah, if anybody else has any questions, feel free to post them on the chat. We'll either answer them live like this, or I'll just answer you on the chat as well.
yeah, so again, obviously you can count, again, if you recall the previous session, we talked about counting the operations. So if you really want to understand which function is quicker, you probably can count like the exact number of operations. So that would be it essentially. And this way, so you can compare your function with this one and find out which is faster. Yeah, but in this demo, we'll stick to this variant. Okay. So now that we know how to swap, we need to, yeah, this is just a pseudocode of bubble sort. Again, it's not complicated. So I hope, again, this is just to give you an idea. So to go with you through this algorithm, and maybe after the session, you will just on your own, you will take a piece of paper and write like step by step, you know, so it's easier for you to process the information. Yeah, let's just go again here. If I reverse, go back to this one. So we know how to swap. Now we need to do this. So we need to compare values, right? And then do all the necessary manipulations. So this is the bubble sort. We have two nested loops. First loop is we shrink the array size backwards. Okay, actually, when we did the preparation, Andrei pointed out that it might sound confusing. So don't worry about it right now. I will show you like what I meant by this. And the second loop, examine values in the subarray and swap if necessary. And then at the end, we just return the sorted array. Okay, so let me go back to this stuff here. Is the size of the font good enough, or I need to?
Yeah, we're good.
Okay, cool. So if I do bubble, so just a second. Yep. So now let's implement a function called bubble sort here. So again, try to do it on the same. Again, it depends how you manage your files, but in this case, I will put if you're working with me in Snippets, then I will. You should put it in the same file, bubble sort function in the same file as swap. So you say just function bubble sort, okay, and then we have again the sorting function accepts an array, so that we will do manipulations on. We define a function called bubble sort, and let me just scroll down so you are not distracted. So here we have bubble sort, and the first, again, if we go back to this pseudocode, we have the first loop to shrink the array size, and now I will explain what I meant. So imagine we have this function. So and right away I will put this example. So after we implement this sort, we should get like, if we have bubble sort, we pass this array, and we should get this result back, right? So in this case, you just, what I meant, so the first loop, what it will be responsible for, the outer loop. If you, again, recall back, I told you that in bubble sort, you bubble the largest value up, so it will be on the right side, right? So we know that after the first iteration over the whole array, the right value, the rightmost value will be sorted, okay? And this is a fact, right? If we go back to here again, we know that 10 is sorted for sure, right? So after this first iteration. And later, so what the first loop will do, it will shrink, again, it does not manipulate the array itself, so it does not change anything like in the array, like it does not change the length of the array. It just changes the scope where you compare the values, right? So the first iteration here, for instance, again, go back to this example, we have 9, 8, 1, 2. So we want to go over all the values, right? Then after the first iteration over the array, we will have probably like 9 will be on the right. So, and we will go, like we will examine only this code, right? So we will know that the value on the right is sorted. And then we examine this and then this. So yeah, so this is what the first loop essentially does. After I do the implementation, we will go through this example. So we will debug it and see how it works. And again, later you will be able to like take your time after the session and maybe have a pen or a marker or whatever you want to, and just write the steps down. So step by step. So here, for instance, we have the first loop, which is again, which will be responsible for the scope, right? So which scope you want to go over. So in this example, the first iteration would be the whole 5 values. Then we will go just over the 4. So actually I have a pen. So right. So here, first iteration, we go over the whole array. Second iteration, we go just over this scope. Next iteration, we will go over this scope. Next iteration, we'll go over this scope, and then just one. So this is what the first loop is responsible for. Okay. I hope I made it clear. I didn't confuse you. So again, this is what the outer loop is for. So we do array.length, and then I is more than 0 and I minus minus. So yeah, so what this loop will do is essentially what I just described here. So shrink the scope, maybe not the size would be the right word. So shrink the scope, right, of the, so here, shrink the array scope backwards. Let's do paraphrase it a little bit. So the inner loop, okay? The inner loop, examine values in the subarray and swap if necessary. If we go back to this example, okay, disable the pen, how to disable it. Okay, okay. Anyways, here you need to compare it, right? So in this scope, the second loop, what it will be responsible for, it will compare different values and swap if necessary. Okay, so this is essentially its role, and let's do that. So for j is 0, and then you go j is less than I minus 1. Why do I minus 1? Because again, I is essentially the length of the scope. So we start from array.length. So we start from this length, and then we reduce the scope to this length, and then we reduce the scope to this length. So this is why I need to iterate from j from 0 to I minus 1. So from 0 to I minus 1. And then I just do j++. And then here, I just do the comparison itself, right? So I say, if array at j is more than array at j+1, okay, so let's probably just go over this example so it makes sense more. It makes more sense, sorry. So again, this first iteration, we have this array. So we first loop, it defines the scope. So the scope is full for now, right? So, and the inner loop, it just iterates over the values in this scope and swaps them if necessary, right? So the first one, we compare 9 and 8. Yeah, we do swap, so 8 and 9. Then next comparison, 9 and 1. So yeah, we do swap because 9 is bigger. The next comparison, 29, yeah, we do swap because 9 is bigger. And now we know for sure the 9 is swapped. 9 is the biggest. And now we need just examine this scope. So the outer loop will shrink the scope down to this one. And now we again examine this scope. 8 is bigger than 1, so we do the swap, 8 and 1. 1 and 8. And then again, similarly, 2 and 8. And now, again, we know that 8 is sorted for sure. And now we examine this scope and we check 1 is less than 2, so we don't do any swaps, and we know that array is sorted, right? So this is how this bubble sort of works. And again, this is what these two loops are, what they are doing. So, and now we compare. So if array at j, so again, if I go to this example, again, imagine first iteration. So we have j's here, and we say if array at j is more than array at j plus 1, then we need to swap, right? Again, I didn't remove this function, I just moved it down so you are not confused. I just call this swap, and I call it on array with indices j and j plus 1, okay? And then that's essentially it. And now we just need to return our new array, and this function should work. So this is essentially bubble sort. And now let's run it and see what happens. So just a second, I need to comment out this part here. I will just remove it. Okay. So as you can see, you get the sorted array, right? So we can conclude that the bubble sort of works. And here, let's try something different. So let's put 7, 11, 23. And if I run it, yeah, we get it in the right order. So 1, 2, 7, 8, 9, 11, 23. So perfect. So this is how bubble sort is implemented. Now we can, what we can do is essentially just put a breakpoint and run line by line. So just a second. Right, put breakpoint here, and I click run, and I don't know where is the run button. Weird. Let's save it. Put breakpoint. You just need to save it in order to put a breakpoint. Okay. So then you click run. Oh, it's happening. Okay. Just a second. Sorry. Swap demo. Mine. Okay. I have. Okay, I have a problem with breakpoints, but anyways, let's just continue. Probably you can debug it by your own.
Yeah, I think you did a good job explaining the algorithm. Like if people have any questions or somebody is still confused, we can assist you on the Discord. Also, yeah, like you could just, this code will be available, by the way. I will actually share the GitHub repository in the comments, so you can all play around with this and check it out. If you want to debug on your own, feel free to do so, or just like as Alexander said, like with a pen and paper, that's the best approach.
Yeah, definitely. I showed you how to debug the swap. To be honest, I found out that yesterday that my computer is a little bit laggy, so that's like another issue. So yeah, again, as Henry said, if you have any specific questions, just ask in the Discord channel, and we will have a repo. You will be able to check it out again. Okay. So then the next one, we will do a small optimization. So imagine we have this array, and we don't need. So okay, let me just again show it to you so it makes more sense. So 5. Where is it? So it's here. So we do it here. So imagine we have this array, and so we do. Let's just go over bubble sort, right? So 5 and 1, we do the swap. So 1 and 5, then another one 2 and 5, then 3 and 5. Let me remove this first so we have less elements. So anyways, then so now at this point we know that this array is already sorted, but still what this function will do, it will check this scope again and again and again. So although we know that this array is sorted, so it still will run on this scope, and it will check 1 and 2, 2 and 3. It will not do anything, and then it will check this scope 1 and 2. So we have a lot of unnecessary operations, and to optimize it, what we can do is just like a small improvement. But we just need can create a flag variable which we'll call swapped. We'll assign it true initially, and then we say here swap is false, and here you would have swap is true. So essentially what it does, it indicates if we swapped. So when we change the scope, we default this value to false, and if we do swap, we put a flag that yes, it's swapped. And here what we do is we say if it was not swapped, then we just break. Okay, so this is just a small optimization that you can do, so we have less operations to go over, right? So it's like, again, you optimize your code a little bit. If I run it again just to check if it works, yeah, it does. So here we have 1, 2, 8, 9, and then 1, 2, 3, 4, 5. So again, this is just to optimize it a little bit. So if we have a nearly sorted array, almost, then this is a small optimization that you can do for bubble sort. Okay, cool. Now let's briefly talk about bubble sort big O. So time is of n squared. Again, we have kind of a little bit improved version of bubble sort. You may encounter some other versions that are worse in like they are less efficient. They are still of n squared, but again, recall from the previous if you watched it, if you didn't check it out, the previous session, we talked that we simplify big O, right? But still, although the same algorithms can have the same time complexity of n squared, we still can choose one, like can compare one or the other, right? By counting probably the operations in this case. So again, you can, the version that I introduced you to right now, so this one is, like I would say, is a good version. I like it. So, and I'm just saying that you may encounter other implementations of bubble sort if you read any article or any explanation. So they might use a different approach. And this is a space complexity. So a space is of 1, so it's constant. Why? Because again, we measure space complexity just inside the bubble sort function, inside the function. So again, in this case, we just create like 3 different variables. So 1, 2, and 3. So swapped I and j. And this is just all 3. And if we simplify it, it will be all of 1, right? So that's it. And now if you can see, n squared is generally not very good right now. So the next sort we will do is merge. And it is improved. So it is way better than this one, than bubble sort. It will be on of n log n. and probably this will be the first time when you encounter like logarithms and time complexity. So yeah, let's just jump in it. So I hope it was not very hard. Like it was pretty intuitive, and like I tried to do my best to explain it to you and make it intuitive again. If you struggle with it a little bit, you can just after the session check again the repository and go over it again and debug it. So yeah. Now let's talk about merge sort. So merge sort is intermediate sort. So if bubble is kind of more, let's call it intuitive. So this is probably how normal human would sort, right? Values. But merge sort is intermediate, so it is less intuitive. So there is a trade-off between efficiency and simplicity. So merge sort is way more efficient than bubble sort, but it's a little bit tricky to understand. It's not hard to implement. It just you need to wrap your head around all the things that will be going on. So again, try now. Do not, if you cannot implement like this algorithm, even bubble sort by yourself, like do not worry. Like it's totally fine. It's probably it's the first time when you learn sorting algorithms, and you just need now to focus on understanding the concept. So the way how the sorting algorithm works, and then later when you practice, you will be able to write it by yourself, right? So right now your goal as a listener, as a participant, you just need to understand how the algorithm works. So anyways, merge sort, it might be hard to understand again, but do not worry, just think about it. Anyways, sorry, we have just two main steps. Actually, before I do anything, I want to show you one thing. So we are talking about different complexities, right? O of n squared or n log of n, but you probably might not understand it right away. So here I have merge sort implementation and bubble sort together in one file. And what this line does, it essentially creates an array of with the length of 100,000 elements, and it just does random values. So we will, and I just want you to show, actually here it should be merge sort, and I will comment it out for now. So right now we will just see, like you will see literally and feel how long it takes to run this bubble sort on such a huge array. So again, bubble sort does not scale well. Merge sort is very good algorithm, and you will see why just in a second. If I click, so again, what this line does, it creates this array with 100,000 elements. And now when I click run, you see bubble sort started, and now we wait. So it's still sorting.
This might take a while. Let's test your computer.
Well, I tested it before. So now you see how long it took. Like it took, I don't know, maybe 10 seconds, right, to run this on 1,000 element array. So again, this is bubble sort, right? So it took like around 10 seconds. I'm not sure how long, but yeah, you just felt it, right? So it's not quick, right? You don't want the user of your application to wait for so long. Now, if I run merge sort, it's instant. You saw it? So again, if I run it, merge sort started and right away. So now you can feel literally how good merge sort is. So I hope it gives you some motivation to learn merge sort. And to be honest, it's I like merge sort, and it's just very good and efficient algorithm. So, and also it again, it makes your brain work and think. So this is another aspect I like. So here we have again 2 main steps of merge sort. Is again not very complicated: split and merge. So I will explain in the next slide how it works more in detail. So it exploits the fact that arrays with 0 and 1 elements in them are always sorted. So for instance, if we have an empty array, it's sorted, right? If we have an array with 1 element, which is 1, we know it's sorted, right? Because we don't need to sort anything. So this is what the property that merge sort exploits, okay? Now let's move forward. So here we have, I have a small visualization to explain to you how this merge sort works. So here we have this array, imagine, right? 7, 5, 9, 4, 2, 1, 8, 3. So again, conceptually, maybe it's just less intuitive, but the implementation is a little bit tricky. But the understanding, you just need to grasp the idea, and it will be fine. So we have this array, 7, 5, 9, 4, 2, 1, 8, 3. And what merge sort does, again, 2 steps, 2 main steps: split the array into small ones, and then merge them together in a sorted order. So we have this array. So we split it into halves. We split it, so in the middle, with the middle. So just do this. So this is the middle, right? And we say 7, 5, 9, 4. And then we split it further. So these arrays, we split it further and further. So it will be here in the middle. So we split here and we split here. And then we split it even more. So it will be, again, divided by, into halves, right? So it will be 7, 5, 9, 4, 2, 1, 8, 3. So our goal, the first step we need to do in merge sort, is to split the array into 0 or 1 length arrays, okay? Smaller arrays. So this is the first step of merge sort. And the second one is to merge these smaller subarrays into sorted ones. So now we take, so for instance, here, 7 and 5, we take them and we merge them in a sorted order. So we don't merge them just to merge. We sort them in a sorted order. So it will be 7 and 5, and if we merge them together in a sorted order, it will be 5 and 7. Then 9 and 4, we merge them together, we're in 9. 2 and 1, 1 and 2. 8 and 3, 3 and 8. Okay, makes sense? Next, we merge even further. So it will be 4, 5, 7, 9. Okay, now here, 1, 2, 3, 8. Okay, and then the last merge will be 1. So again, from this here. So let me take a pen. Where is it? Okay, here. So 1, then 2, then 3, 4, 5, 7, 8, and 9. Okay. So now I hope you have an idea like how it merge sort works. So again, just it's unusual. Probably you've never seen something like this before. But if you are new to algorithms, so again, 2 main steps: split and merge. Again, we split it here, and then we merge them. We merge it. If we go back, another demonstration that you might take as a, so here, merge sort. So let's create an element with the last element. So here, let's do it with like this. So you can go to this website and it will go like step by step if you want, right? So here you will run it. If you run it, how to run it? Okay, sort go. Now let's do it fast. No, quick, slow. Okay. So again, it splits into different colors, you see, and now it merges it together. So this is how merge sort works. Essentially, again, so again, different colors mean different subarrays. So this is like you merge it again, and then, and finally you end up with a sorted one. So this is it. To be honest, I made this this slide because I find it a little bit more intuitive than this one. Yeah, so it just to explain to you how the merge sort works. Again, are there any questions about merge sort in the chat?
Not yet, but yeah, if anybody asks anything, please post them. We hear what's your opinion.
Okay. So let's we have just very yeah, not too much time left. So we will do the implementation very quick. So again, the first step I want to do is to merge the array. Okay. So the first step would be like we will have one helper function, and which is called merge, and we'll have main function merge sort, right? So the first step I want to do is to implement this helper function before we do the merge sort itself. So the goal of this function is to imagine it takes two sorted arrays, so 4, 7, 9, and 1, 2, 3, 8, and it merges them together into one sorted. Again, we assume that the given arrays are already sorted, okay? So given two sorted arrays, and we merge them into one sorted, okay, in a sorted order. Time and space complexity are n plus m. I will explain it later. So of n plus m after the implementation, so it makes more sense. So let's now just jump into implementation itself. So now again, if you are following with me, just do merge sort demo. Okay. And now I will go here and okay. Let's just write this function, which is called merge, and this is what we should get. So imagine we have this function merge, and I later, like what we need to end up with, again, we assume that both of these arrays are sorted, okay? So we end up with 5, 9, 11, 10, then 11, then what? 15, 16, and 17, right? So this is what this method should do. It should return this array to us. So yeah, now let's do it briefly. So the pseudocode for this function is create two pointers. One, this function will accept two arrays, array 1 and array 2. Both of them, we assume that they're sorted. We need to create two pointers over them and an array to be returned, okay, is a result array. And then we will have 3 loops to merge two sorted arrays. So now let's just do that. So here we have function, which I will call merge, okay? And it accepts array 1 and array 2. Okay. We assume that these arrays are sorted, okay? And we have I, which is 0. So I will be pointer over part 1, array 1, sorry. Then we have j, which is pointer over array 2. Okay. And then we have a result, which will be an array. Result, which will be an array. And it will be returned, to be returned, okay? Returned. Cool. Now we just need to, again, going back to the pseudocode, we just need 3 loops to merge two sorted arrays. So I will use 3 while loops. And so the first one will be over both arrays. Then the second loop will be over array 1. And maybe I just need to, let's step by step. So over both arrays. So we have a loop, which is while, and we iterate over both arrays. So we have this and this. So how it should work? Imagine, so let's maybe take a smaller example. So like this. We have a result array, and so how this function will work? It has 2 pointers over, like, again, we have 9 and 11, and then this array. So one pointer, we have one pointer called I, which is over the first array, and another pointer called J over the second array. Okay, and this is the result. So the first loop, what it will do, it will say while I is less than array 1 dot length, and then J is less than array 2 dot length. Then you just say, and then you do some specific comparisons, what is bigger. So if array 1 at I is less than array 2 at J, then we say result dot push array 1 I. Then we increment I. And else we do the same stuff, but we do the same thing, but with the second array, right? So array 2 into array J. Don't worry, I will just go briefly over how it works, like in more detail. So this is the first loop. So what it does behind the scenes, imagine we have these 2 arrays, and we want to merge them together. So we compare. So here we say what is bigger. Initially, I and J are 0. So we compare what is bigger, array 1 at I or array 2 at J. So array 1 at I is 9. 9 is bigger than 5. And so it means 5 is less than 9, right? So, and we take the smallest value and put it into our result array. This is our result array, so 5. And then we increment this pointer. Now we compare what is bigger, what is less. 9, what is smaller, 9 or 10? 9 is less than 10, so we put it into our result array and increment I. Now the next step is what is smaller? 10 is smaller, so we put it into array and increment J. Now again here, what is smaller? I. The 11 is smaller, so we put it here, and now we increment it like this. So now you see we have, so what this does, this loop almost does this job almost, right? So if I comment it out and I run it, and I just don't return it. Okay, we need to return it, so let me return a result. You see here, this does what I have here, right? But where is 15, right? We cannot just drop it. So what the next 2 loops will be, just to pick up all the rest, right? That is remaining in either one of the arrays, okay? So essentially, we have just while I is less than array 1 dot length, and then we just do result dot push. Maybe I will just copy and paste these loops because like we have time limitation. So yeah. So essentially, what these do, I just set it to while loops. So 1 will be over array 1. So it just iterates over the remaining parts of the array, right? So here we are done. So this loop will not be run. Why? Because I is already beyond the scope, right? But J is in here. We still have one element in here. So what we do, this will be just run one time, and it will add it to the result. Okay. So again, essentially what these two loops do, they just put the remaining parts into this array. So if I run it here, and now we have this merged array. Okay. So I hope it was clear. Again, you will be able to practice it again. So essentially we did this part, right? So we did merging part, this one. But now we need to do just to split it, right? So this is this part, the second part will be very easy to write, like it will be just 5 lines, but it a little bit tricky to understand because it involves recursion. Okay, so here we have okay. Now let's I want to explain briefly why it is time and space complexity n plus m, and it is the length of the first array. So this array, m, so n length. And this has the length of m, right? So what it does, essentially we iterate over either one of them, like both of them. Like we need to visit every single element. So this is why we have n plus m. Okay, so and space is the same because it will be, we create a new result array, right? So here we create a new result array, and it is essentially the length of this plus the length of this. Okay, so this is why space is also n plus m. Okay, now, yeah, final steps is just essentially this merge sort function itself. Now let's just recursively, so we split up the array into halves. You, like, to be honest, it was kind of a prerequisite for a merge sort, like to know recursion. If you're not familiar with recursion, just check it out on YouTube, or, you know, just to get more familiar with it. Because if you have not seen it before, like what recursion is, it will be a little bit crazy. But yeah, like the implementation itself is just 5 lines. So split up the array into halves. So, and then to do this, we have smaller array. Once we have smaller sorted arrays, merge those into a big sorted one. So this part, like all of this, we do it recursively, right? And now if I go here, this is essentially the literally line by line, almost implementation of this function. So base case, every recursive function has a base case. In our case, it will be, in this scenario, it will be array length is less or equal to 1. And then we need to calculate the middle where we want to split the array, right? And then we just merge 2 subarrays created from the path. Okay. Let me just comment this one out. Okay. And now, okay, we have just 6 minutes left. So instead of writing this function, actually we'll just copy and paste it and walk through it. So this is essentially it. We have this base case, which is array length is less or equal to 1. So we return array. So again, we concluded that what merge sort exploit is that every array with the length of 0 or 1 element in it always is sorted, right? So this is what we do. This is how you split. So you recursively split it until you have the length of less or equal to 1, right? So this will be the base case. And here, essentially, we calculate the middle. So again, if I go back to this pseudocode, calculate the middle here. And now we call this merge sort recursively to split the arrays into halves, right? So this will be the left half, this is the right half, and this is how you did recursively. Again, unfortunately, right now we don't have a lot of time left. So I do suggest you, maybe you can find something like a merge sort, article about merge sort, like how this part works. Like we did this function, how to merge them, but maybe like you should just, if you're familiar with the recursion, that's perfect. But if you're not, first of all, learn what, like check what the recursion is, and then just debug it. Like literally walk through like pen and paper. That's a perfect teacher. You will just go over this simple example, and it will just do the work, right? So, and do the work instead of or just debug the function. Okay, so you will just go line by line and write every single iteration. Initially, I planned like to do it with you, but again, due to time limitation, unfortunately, I cannot. So yeah, we do middle, left part, right part. So we do it, we split them recursively, and then we just merge left and right part. Okay, so essentially the implementation of merge sort here is very simple, kind of, if you know recursion. It's a little bit tricky to understand. So again, debug, maybe you can go like step by step marker and on a board, just again, do the step by step walkthrough. So that was essentially it, like about the merge sort. Again, I'm sorry that probably it took me a lot of time to explain bubble sort or something, so it took a little bit more than I planned. Anyways, and finally about time, again, it's analog n and space is n. Space is n because we create these in merge function, we create this result array, and this is the reason why we have this space often, right? It will not be exactly like often, but after simplification, it is often. And time, I will just explain it briefly. So it's log of n decompositions. So again, it is how you calculate it. So imagine a logarithm with a base of 2. And then the number of elements in the array is 8. So logarithm of 8 with a base of 2 is 3. So, and you can see that we have 1, 2, 3 decompositions, and that's it, right? So this is, again, log of n decompositions, and then of n comparisons per decomposition, and we end up with this, time complexity. Okay, so 1 minute left. I hope I didn't scare you too much. Hope it was at least somehow helpful, and it introduced you to some, unusual ways how you can think about sorting. Again, there are many different ways how you can sort elements. It's just one of them. So yeah, I hope you enjoyed, and definitely keep on learning. Check out maybe different other algorithms, and maybe if you want to rewatch it again on YouTube, or I know, again, we will put some recommended resources on a GitHub repository. So if you want to check it out, you will be able to. Okay, so any questions?
Yeah, thanks for the presentation, Alexander. So yeah, we had just one question actually, which covers, apart from the sorting algorithms, it's also touches base on other things. So I'm just gonna pull it up.
Mm-hmm.
So Thomas is asking if what do we think? What is our opinion on lead code, interview cake, and cracking the coding interview? So all of these, actually, I needed to Google some of these because I'm not familiar with all of them. Lead code is a quite popular website. I haven't tried it myself, but it's definitely the one to go and practice the algorithms and data structures on. Interview cake seems to be another resource to practice and learn data structures and algorithms. And Cracking the Coding interview, I think that's a book, right? Like that's quite a popular book that's also a nice resource. To be completely honest, I haven't tried any of those. I can, once again, like if you are looking for ways to learn data structures and algorithms, check out our Discord and our channel on Discord. We have a lot of good resources there, and also our GitHub repository includes some resources for you to check out. But definitely, I don't have any opinions on those, but I would definitely try them if you.
Yeah, I can share my experience. I have tried Lead Code like during the summer just for fun, and also I read a little bit of Cracking the Coding interview. So I bought this book. So it's actually good, like interesting. You can definitely. It will help you. Like it depends what you want, right? If you want to prepare for an interview, right, to write the algorithms, definitely like you should buy it and try, because it has a lot of hints, like a lot of different like explanations how you probably need to approach different kind of problems. Obviously, you have a lot of different resources online as well, so it's not the only one. Lead Code is good because and HackerRank, right? So these are two that I have experience with, and like I like Lead Code. You even don't need to buy Prime membership there to like practice the questions. I believe it's yeah, it's a good resource. Like you should try it. And yeah, even without Prime membership, it's very useful, and it will help you a lot to prepare and for an interview, or just to practice different questions and the way you think to improve your critical thinking skills. Yeah, so definitely do that.
Yeah, I think like theory and algorithms and data structures is very important, but it's also very important to practice those. So you want to go and like try something out, definitely Lead Code or HackerRank are the resources to go to. Yeah, that's thanks so much for the question. That covered a lot of things. Yeah, if anybody else has any questions, then yeah, feel free to post them in the chat. Yeah, I think we can wrap up if anybody else.
Okay.
Thanks everybody for joining. Next session will be on a Saturday, so it won't be at the same time. It will be Saturday at 12 p.m. I believe. We will be covering some graph algorithms, and I hope it's going to be interesting for you to learn those, and we'll cover those in more detail next time.
Yeah, and we will do pathfinding and yeah, more in detail. We will implement how to store graphs. Again, we will have some demo, so definitely check it out if you're interested. Yeah, to be like, I really like graphs. It's one of my favorite topics. So yeah, you should check it. Yeah, great.
Yeah. Thanks everybody for the support, and see you next time. Bye-bye.
Yeah, see you. Thank you.